So number 4 is a vertical acceleration question. Numbers 1 and 2 were both horizontal accelerations. And I wanted to do an example with a vertical acceleration. It's the same process, but for whatever reason, it proves to be a little bit more confusing for students. So number 4, a 4,500 kilogram helicopter accelerates upward at 2 meters per second squared. Okay, what is this given? 4,500 kilograms. Mass. Kilograms is mass. It is not weight. So I'm going to label that as mass. 4,500 kilograms. And then upward acceleration of 2 meters per second squared. What do we label that as? The acceleration in the y, up, yes, is 2 meters per second squared. Okay, so again, I want to reiterate, I did this last time. Gravity is not the acceleration in the y if there are other forces acting on the object. It is only the acceleration in the y direction if the object is in free fall, if the force of gravity is the only force. A helicopter accelerating upwards, is there going to be an upward force acting on it? Yeah. Okay, free body diagram. You know that there is a weight, right, to this helicopter, force of gravity. And then if it's lifting off, it's accelerating upwards, there's got to be another force. And they tell you here that it's not a normal force, because once it lifts up off the ground, there's no solid surface pushing on it, supporting it anymore. So I'm going to call it sort of a generic force. I'm going to call it the lift force. Okay.
Can you try L?
Yeah, force L would be fine. Notice how I drew this. There is an acceleration, so the forces are unbalanced. It's accelerating upwards, so the larger of the unbalanced forces needs to be pointing up. Net force in the x direction is 0, so I'm not going to do that. Net force in the y direction would be the upward force minus the downward force, the lift force minus the weight, the force of gravity, equals the mass times the acceleration in the y. Are there any questions so far? Part B. Calculate the weight of the helicopter. So the weight is mass times the acceleration of gravity. The mass was given to us, 4,500 kilograms. The acceleration of gravity is 10 meters per second squared. That's 45,000. What's the unit for weight? Newtons. It's a kilogram meter per second squared, which is a newton. Just so I can organize my information, I'm going to put that in my free body diagram. Questions about part A? Part B. It says, oh, that was part B. We only have one left. Part C. What lift force is exerted by the air on the propellers? So there's my lift force. That's my unknown. So part C, the lift force, I've already got the equation written out. There's my equation. I'm going to rewrite it again because we have to solve for lift force. So the lift force minus the force of gravity, all the forces up minus all the forces down, is equal to the mass times the acceleration in the y. If I solve for lift force, how do I move the weight, the force of gravity? Add it, because it's subtracting right now. So the lift force is equal to the mass times the acceleration in the y plus the force of gravity. Substitute my givens in. The mass is 4,500 kilograms times the acceleration in the y We labeled that as 2 meters per second squared. Plus the weight, the force of gravity. I solved for that in part B. 45,000 newtons. So 4,500 times 2 is 9,000, right? 9,000 plus 45,000 is 54,000 newtons. I can do my quick check again. If the weight is 45,000, because it has an upward acceleration, the lift force needs to be bigger. Does everyone agree 54,000 is bigger than 45,000? Okay. If I accidentally subtracted when I should have added over here, then my answer would have been smaller, and when I compare it to my free body diagram, I'd recognize that there was something wrong.
Isn't it you're adding 45,000 and 45,000 because MAY is already. I was just kidding.
Questions? Other questions?